Hello and welcome to today's lesson on visible light, which is part of the waves topic in GCSE Separate Science Physics. So in today's lesson we're going to look at understanding the properties of the visible spectrum. Now if we're successful and we learn in today's lesson, we can explain how colour filters work, understand how light can transmit through transparent or translucent materials, in detail how the colour of an opaque object is determined by which wavelengths are strongly reflected, which falls into the following part of the AQA Physics Specification 4.6.2.6, which is visible light, which is a separate science only piece of content. Now previously we've looked at the different parts of the electromagnetic spectrum. Now the continuous spectrum of waves is called the electromagnetic spectrum, and we can group the different parts of the electromagnetic spectrum into different regions, and the waves in each region have similar wavelengths and frequency, but all electromagnetic waves, no matter what region they belong to, all have the same speed. So you've got to memorize the different regions of the electromagnetic spectrum. So what do we have here? We have the radio, then the micro, then the infrared, then the visible, then the ultraviolet, the X-ray and the gamma ray. Now previously, when we've looked at these ideas in these different parts of the electromagnetic spectrum, we noted something special about the visible light section of the electromagnetic spectrum. And that is that the visible light section is the only part of the spectrum we can detect with our eyes as humans. Because as humans, we detect a difference in frequency in wavelength in visible light as colour. Now it's important to note that we observe long wavelength or low frequency visible light as red. We observe medium wavelength and frequency visible light as green, and we observe short wavelength and high frequency visible light as blue. Now light which is at a wavelength too long to be observed by human eyes is called infrared, literally beyond red, whilst light which has a wavelength too short to be observed by human eyes is called ultraviolet, literally very blue. Now as humans we can observe objects with our eyes as different types depending on what they do when they encounter visible light. So you've got transparent objects, translucent objects and opaque objects. Now transparent objects transmit all incident light that enters the object. No light is absorbed by the object. So for example, glass in a normal window. Now the transmitted light travels through the object, which is why you can see clear images through transparent objects. A translucent object lets light pass through them, but the light is scattered or refracted. Now this happens as there's lots of changes of material inside the objects. There's many internal boundaries inside a translucent object. Now an example of a translucent object is frosted glass. Now you can see light passes through a translucent object, but you can't see any images because it's been scattered and refracted. Now opaque objects absorb all light that reaches it. The light will either be reflected or absorbed, but no light is transmitted through an opaque object. Now an example of an opaque object could be wood. Now you can't see through an opaque object. So to clarify, in a transparent object all light is transmitted through the object. In a translucent object all light is transmitted through the object, but it's scattered as it does this. And finally, in an opaque object all light is either absorbed or reflected by the object. So it can either be absorbed by the object or reflected back off the object. So to clarify a few things, transparent objects transmit all incident light that enters the object. No light is absorbed by the object. Translucent objects let light pass through them, but the light is scattered or refracted. This happens as there's lots of changes of material inside the object. Now it's also important to note that an opaque object will either reflect visible light or absorb visible light. Now the wavelengths which are absorbed or reflected determine the colour of the opaque object. Now the wavelengths which are reflected by an object give the colour of the object. So an object which strongly reflects blue wavelength visible light will appear blue. An object which strongly reflects green wavelength visible light will appear green. And an object which strongly reflects red wavelength light light will appear red. Now all other wavelengths will be absorbed by the opaque object. So a red coloured object absorbs green and blue wavelength visible light. A green coloured object absorbs red and blue wavelength visible light. And a blue coloured object absorbs red and green wavelength visible light. Now if an object reflects all wavelengths of visible light equally, it will appear white. If an object does not reflect any wavelengths of light and absorbs all, then it appears black. So the colour of an opaque object is determined by which wavelengths of light are more strongly reflected. The wavelengths that are not reflected are absorbed. If all wavelengths are reflected equally, the object appears white. If all wavelengths are absorbed, the object appears black. Now, filters are transparent materials which work by absorbing certain wavelengths or colours and transmitting other wavelengths or colours. Now, it's important to note that a filter will let some wavelengths of visible light pass through it, but the filter will absorb some wavelengths of visible light. Now, a filter will transmit wavelengths of visible light which is the same colour as the filter. A filter will absorb the wavelengths of visible light which are not the same colour as the filter. So a green filter will transmit wavelengths of green light but absorb all other wavelengths of visible light. A red filter will transmit wavelengths of red light but absorb all other wavelengths of visible light. And a blue filter will transmit wavelengths of blue light but absorb all other wavelengths of visible light. So what have we learned in today's lesson? Each colour within the visible light spectrum has its own narrow band of wavelength and frequency. Colour filters work by absorbing certain wavelengths and transmitting other wavelengths. The colour of an opaque object is determined by which wavelengths of light are more strongly reflected. Wavelengths that are not reflected are absorbed. If all wavelengths are reflected equally, the object appears white. If all wavelengths are absorbed, the object appears black. Objects that transmit light are either transparent or translucent. Now you should be able to explain how the colour of an object is related to the differential absorption, transmission and reflection of different wavelengths of light by the object. You should be able to explain the effect of viewing objects through filters or the effect on light of passing through filters, and finally explain why an opaque object has a particular colour. So if you've been successful, you should be able to explain how colour filters work, understand how light can transmit through transparent and translucent material, and detail how the colour of an opaque object is determined by which wavelengths are strongly reflected. Thank you very much for listening to today's lesson on visible light, which is part of the waves topic in GCSE Separate Science. Thank you very much and have a lovely day.